In this video, I'm going to find the radius of convergence for this function here. Same kind of thing. I need to basically try to write this as a series. It looks kind of like a geometric series. It kind of looks a little like that 1 over 1 minus x. We just have to kind of wrangle it around a little bit. So a couple of things here. Number one, I can factor out a 3. Okay, so I can write this as 3 times. I can factor out an x from the top too. So 3x times, now I've got a 1 on top. I still have a 1 plus x squared on the bottom. Remember, I want it to be 1 minus whatever my input is. So I'm going to rewrite this as 1 minus negative x squared. Okay, so we're replacing an input of x with a negative x squared. Okay, so the normal series 1 over 1 minus x would be the geometric series 1 plus x squared and so on. We're replacing the inputs here with negative x squared. So it's going to be 1 plus the input squared plus the input cubed and so on. So we've got a negative x squared, we've got a negative x squared squared, we've got a negative x squared cubed, and so on. And so if we write out a couple of terms of this sequence, that's going to be 1 minus x squared plus x to the 4th minus x to the 6th, and so on. Okay, so we're going to have even powers. It's an alternating series. Okay, now the whole series was supposed to be multiplied by 3x. Okay, so we multiply this whole thing by 3x. We're going to get 3x minus 3x cubed plus 3x to the 5th minus 3x to the 7th, and so on. Those are terms of the series. Okay, again, I'm not real good at looking at these and trying to figure out the pattern. If you can do that, that's great. I'm a lot better at going back to kind of the basic 1 over 1 minus x series is the series, it's x to the n, and then trying to substitute in values. So what are some extra things that have happened here? Well, each term is getting multiplied by 3x. It's going to be an alternating series. So to be an alternating series, I'm going to need a negative 1 to the n. Okay. Normally it would be x to the n, but in place of x, we've substituted a negative x squared. So we could say, now I took care of the negative here, but it's going to be an x squared to the n. And then each of the terms is being multiplied by 3x. So we're going to have an extra 3x here. So if we put all this together, you're going to have a negative 1 to the n, you're going to have an x to the 2n, and you're going to have an additional x, and you're going to have a 3 all being multiplied. So in the end, that's going to be 3x to the 2n plus 1. You add the 2 exponents there, and then you've got that negative 1 to the n out in front, and that's your regular series representation. Okay, so let's put all this together now. So what does this actually look like? Well, this is the series from 1 to infinity, or 0 to infinity, sorry, of negative 1 to the n times 3x to the 2n plus 1. Okay, that's what that series would look like. Okay, and so to find the radius of convergence, we just need to know how far above the center we can go, how far below the center we can go. Really, we need to find the interval of convergence. But it all comes directly out of the ratio test. Should be able to substitute everything into the formula and see what's going on there. So let's go ahead and try it. It says we're going to take the limit as n approaches infinity of the absolute value of the n plus 1 term. Okay, so you've got negative 1 to the n plus 1. You've got just 3. And be real careful here. You're subbing n plus 1 in. The whole n is being multiplied by 2. So the n plus 1 would be multiplied by 2. That's going to give you a 2n plus 2 plus 1. So you're going to get x to the 2n plus 3. And that's going to be really important in our final answer. Okay? We're dividing by the nth term, which is just this guy, the original. So it's negative 1 to the n times 3 times x to the 2n plus 1. Okay? Again, all of these ones are going to cancel all but one of those negative ones. The absolute value there is going to give us both positive and negative signs in the end, so it's not really going to affect anything. Again, if you just want to ignore the negatives altogether, you can. Anyway, those are going to come out in this case, all right? The 3's are going to cancel, okay? 2n plus 1x's are going to cancel 2n plus 1x's there. That's going to leave us with 2x's left. We're going to have an x squared, okay? So let's put all this together. We want the limit as n approaches infinity of x squared. Notice there's no n left. And we need that limit to work out to be less than 1, okay? Because there's no n there, as n goes to infinity, this is just going to stay x squared. It doesn't affect anything. If I want to take the absolute value off, I have to say that x squared would be between -1 and +1, okay? And this is kind of interesting, actually. So technically, we want to solve for x here, and we want to figure out what x would have to be in between. We need to take the square roots here. You can't take the square root of -1, okay? However, you can take the square root of 1. It could be 1, or it could be -1. So again, we're going to take the square root here, we're going to take the square root here, and it's going to leave me with x being between +1 and -1, okay? Again, coming from those two values right there. So this is called the interval of convergence, okay? Technically 0 is in the middle of those two values, so this would be centered at 0 if you were asked that, okay? The radius of convergence, you can go up 1 from 0, you can go back 1 from 0. So the radius in this particular case is 1. This is centered at 0, and that's what's going on. And again, if you're thinking, are we just going to get a radius of 1 every time? It does kind of seem like that. It may be a little bit more common in some of these problems, but not in every problem. So I'll show you one more example where I promise you the answer won't be 1 coming up next.